Debugging is useful to figure out what is going on under the hood in a program. It helps to quickly identify the source of errors or bugs in your code so you can resolve them more easily. Here I will walk you through a quick overview of the Eclipse debugger for Java. To walk you through the debugger, I will be using this rectangular prism class, which is fairly simple. It represents a three-dimensional rectangular prism and contains methods to perform basic computations on rectangular prisms. The source code will be made available for you to look through everything on your own. In the rectangular prism tester, we create two rectangular prisms. Then we compute the surface area and volume of the prisms and store these values in an array and print the results. Again, this code will be made available to you. The debugger in Eclipse allows you to set breakpoints on any line in your code by right-clicking or double-clicking to the left of the line, where the line numbers are. Breakpoints cause the execution of your code to halt at that line without executing the code on the line. Let's go ahead and run the debugger by clicking this bug icon. Note that you might see an error in your console if you have a Mac. It is safe to ignore this. This will take us to the debug perspective. You may be prompted to confirm the perspective switch. Click Yes and check the checkbox. The debug perspective has a lot of useful tools to see what's going on in our code, which we will get to later. Now we see that the line where we toggled the first breakpoint is highlighted. Note that this line has not been executed yet, but the code up to this point has. So we have executed lines 1 through 4, and you can see in the variables pane that prism1 has been instantiated. Up at the top toolbar, you will see several icons that you can use to walk through your code with the debugger. The first icon, Resume, will resume execution of the code and will stop either at the next breakpoint or when the code terminates if there are no other breakpoints. The Terminate button will terminate execution. Here we will click Resume, which will bring us to our second breakpoint. Now we have executed the next 4 lines of code, lines 5 through 8, and both prism1 and prism2, along with the computations array, have been instantiated, which we can see over here in the variables pane. Now we will look at the Step Into button in the top toolbar. Step Into will execute the current highlighted line of code and go to the next line. If the selected line is a method call, the debugger will step into the associated code. Here we are calling the compute surface area method on prism1. So we will call step into the compute surface area method in the rectangular prism class. The next line of code to execute is highlighted here in green, and we'll call the compute rectangle area method. If we click step into again, the debugger brings us to the compute rectangle area method. You can also see the values of the instance variables, L and W, in the variables pane. If we continue to click step into, we will walk through the remaining lines of code of the compute surface area method in a similar way. Now we can see the instance variable S1 has been set. Now instead of stepping into the next line, we will use the step over, which will execute the call without stepping into it with the debugger. Then we can click Step Return, which will finish execution of the current method and return to the caller of the method. We can then step into the next line, which will compute the volume of prism1. Now we are taken to the Compute Volume method, which we step through calling Step Into as before. If we continue to click Step Into, it will execute the code line by line in a way that will allow us to analyze it and see how the variables are changing or being set. You can continue to click Step Into going line by line, or you can click Resume to run until the program terminates, which is what we will do. You can now switch back to the Java perspective. The debugger in Eclipse allows us to change variables at runtime to see how they affect the execution of our code. Here I will run through the same rectangular prism tester using the debugger as before. After reaching the first breakpoint, I will simply click Resume this time to proceed to the next breakpoint on line 9. If we look over at the variables panel, we can see the values of the instance variables of prism2. But if we click on the values, we can actually modify them manually. Here I will change all 3-dimension values to 10. Now when we click Resume, we will see our program's output changed, reflecting the changes we made to the variables using the debugger. Now we will walk through a simple example of how you could use the debugger to identify errors in your code. Here we have the multi-rectangular prism tester, which is similar to the rectangular prism tester. We will create several rectangular prisms and store them in an array. We will then call the compute volumes method shown here, which will take the array of rectangular prisms as well as an array of doubles, and will walk through the array of rectangular prisms and compute the volume of each prism and store the result in the array of doubles. We will then print the result. As this code is currently written, when I run it, it throws an exception. We can use the debugger to help us figure out where things might be going wrong here. The error message states that the error is occurring on lines 14 and 30, so it is occurring within our compute volumes method. We can set a few breakpoints a few lines up from where we call the compute volumes method to see what is happening. I will put a breakpoint on lines 21 and 30. Now we can run the debugger as before. Remember that the debugger runs the code up to the breakpoint. So here with the breakpoint on line 21, we have not yet created the prism array. Now we will begin stepping through the code. You can now inspect the prism array in the variables panel and see each index is set to null, as we would expect. Now we will continue to step through the code. We also see that we have created the volumes array. Continuing to step into the code will bring us to the rectangular prism constructor. Note that we also go into the object class. You can set up filters for your debugger so that you will not walk through this. Now we see that the prism array is being populated with rectangular prism objects. We can inspect them as well to see if they appear as expected, which they do. Now we will click Resume to move to the next breakpoint. Now we can step into the next line, executing the compute volumes method. This will bring us to the method, and we can step through it using step into to see what is going on. Like before, the debugger will bring us to the compute volume method, but we can use step over if we do not want to walk through that method. Notice that you can see the variable I changing and the vol array being populated. Now as we continue to step through the code, we see where the exception occurs. Looking through the variables panel, we can see the source of the error. We are trying to place a value into the vol array at index 4, but the vol array has a length of 4. From our code, we can see the vol array is the volumes array we passed into the method. So we can change the volumes array to an array of length 5 to fix the problem. This was a bit of a trivial example. However, you can use a similar technique to better understand where things are going wrong in your code. The debugger is particularly useful when your code isn't throwing any exceptions, but just not working the way you expected. It will allow you to see under the hood and determine if the code you wrote is in fact working in the way you intended. The debugger in IntelliJ is very similar to the one in Eclipse. Here I have the same rectangular prism tester example, and I will quickly walk through how you would run the debugger in IntelliJ. First, we will need to set breakpoints as we did before. I will put breakpoints on lines 5 and 9. You can set breakpoints by simply clicking in the area to the left of the line. Clicking on a breakpoint will remove it. Now we can run the debugger by clicking this bug icon. This brings up the debugger. Like in Eclipse, we see the line where we toggled the first breakpoint is highlighted. Note that this line has not been executed, which we can see if we look at the variable panel at the bottom. Here we see Prism 1 has been instantiated, but not Prism 2. We can access the stepper for the debugger in IntelliJ in the top menu under Run. Here you will see methods equivalent to those in the Eclipse debugger. We will click Resume Program to resume the execution of the code, bringing us to the next breakpoint on line 9. Now we have executed the next 4 lines of code, lines 5 through 8, and we can see in the variable panel that both Prism 1 and Prism 2 have been instantiated, along with the computations array. The debugger in IntelliJ also has a Step Into button, which works similarly to the one in Eclipse. It will step through the code line by line, and if the line to be executed is a method call, the debugger will step into the method, allowing you to see what is going on in the method execution in more detail. This will bring us to the compute surface area method. We can continue to step through the code with Step Into to walk through this method line by line. Note here I am using a keyboard shortcut, F7, to step through the code. Now we can step into the next line, which will bring us to the compute volume method. Step out works similarly to step return in the Eclipse debugger. It will finish the execution of the current method and return to the caller of the method. The debugger in IntelliJ also has a step over button, which works like the one in Eclipse. It will allow us to execute the current line and go to the next without going into any of the methods. Resume will run the code until it reaches the next breakpoint, or until it terminates, as we see here. If you plan to work with IntelliJ, I encourage you to go through the multi-rectangular prism tester tutorial that was presented earlier in Eclipse on your own with the IntelliJ debugger using the methods explained in this tutorial.